Hello everyone, my name is Luke Hanks and this is my Lab 5 video for Physics 2212. And so the purpose of this lab is just to see a real-world case of Faraday's law and then create a computational model in GlowScript that we're going to use to predict the motion of the real-world case, which was just dropping a magnet through a conductive tube of aluminum foil. And so the results that I got were that the model shows the magnet takes 1.07 seconds to fall and the experiment shows that it takes 0.933 seconds to fall. So here are the physics principles. First equation is just Faraday's law, and the second equation is just the formula for the change in flux. And then the third equation is just a magnetic force on a current, or created by a current rather. And then the fourth equation is just what we use to calculate sine of theta, which is the magnitude of the magnetic dipole moment with the magnetic field. And then Lenz's law, which is just that an induced current has a magnetic field of its own, which opposes the change in flux. So here's my experiment. Here's the video, or one of my 5 videos I used. And so I thought this was a really cool experiment, just the way it felt really slow. But on the left, you can just see some of my experimental constants I found. And my average fall time was 0.933 seconds. So here's my model. And the model calculated it would take 1.07 seconds to fall. So any discrepancies between the model and the experiment, I came up with 2 reasons. I noticed that the magnet rotates as it falls in the tube while I did the experiment, which could potentially affect the orientation of the magnetic field, which might make it fall slower. And then there are also some inaccuracies that can result from measuring the duration through video, just because of the limitations of that technology. And then, so here's my coding. So the first part is just me inputting my experimental constants for my aluminum foil and my bar magnet. And I use the magnetic dipole moment I calculated from lab 3, which is just 1.848. And so my second coding slide, I just have the 2 functions I use to calculate the magnetic field for a bar magnet. And then the second function is just calculating the change in flux with respect to time. Alright, and my coding, my third slide, I had the equation for the gravitational force, the current on the ring, and then at the very bottom you have the magnetic field at the ring, that equation. And so my last coding slide, I have an equation for the net force, and then the velocity and position update equations are also encoded. So what if and why? So what if the resistivity of the conductor were reduced as close as possible to 0? And how would the dynamics of the falling magnet change? So lower resistivity means that the current would be higher, so it's going to result in a slower fall time because the magnitude of the induced current would be greater. And then what if holes or slots were cut into the tube? How would this affect the ring currents in your model? So this basically means that there are less rings of atoms or aluminum that you can have, or that can have an induced current, so the magnet's going to fall faster. And that's my lab. Thank you so much for listening. Grand.